Hi everybody, I'm Silvia Piedracoba from the Mar, Spain. I'm going to talk about new products and services based on HF radar data in the RAIA Observatory, Northwest Iberian Peninsula. Okay, RAIA Observatory is the oceanic observatory of the Iberian margin. It supports the development of operational oceanography along the Northwest Iberian coast and was implemented through collaboration of partners of Galicia and Portugal. Here we try to reflect the idea of the observatory. RAIA relies on three basic pillars: an observing infrastructure, the modeling capabilities, and their operational implementation to create products and services through that will be disseminated through the portal of RAIA. Okay, the in-situ observing infrastructure includes coastal and open sea buoys, gauges, meteorological stations, and HF radar, making data available in real time. Partners also contribute data from routine samples campaigns such as weekly CTDs, among others. And related to the HF radar systems was born RAIA project, the current project from which new products are being developed. The RAIA project aims to update and extend beyond the Galician border the HF radar network that has been operating since 2011. The project will allow the establishment of cross-border collaboration beyond the physical infrastructure and developing a sharing strategy of maintenance procedures, validation, and data processing on both sides of the border, as well as easy and public access to all the information. Besides, and no less important, new products will be developed to exploit the potential of this technology. These are the lines work of the project: consolidation of a cross-border HF radar with installation of new sites, data validation and management, spatial data infrastructure, and products for end users. All of them are related to each other in a circular way. I'm going to focus my talk in products derived from Activity 2 and the Activity 4 itself. From Activity 2, I want to highlight that in order to assess the performance of HF radars, two designs of Lagrangian drifting buoys with different communications, GPS and GPRS, have been made with the standard materials and of the shelf electronics to keep costs as low as possible. These buoys are being used to assess the accuracy of surface currents by HF radar systems. Other achievement reached in the project was a web tool to get data quality monitoring real time, based in radial currents obtained from each site or station. This is the RADQC. This website is under construction by now, and we hope it will be open in 1 or 2 months. Okay, regarding the Lagrangian validation, several experiments were carried out along Galician North Portugal coast and also in the Ria de Vigo. Some of them were made in collaboration with Meloa, My Coast, and Palacos project. One of these drifters was emitting position data for 171 days. Concerning the new tool, RADQC, the most important functionalities displayed in the web tabs from left to right are the following. Info gives access to information overview of the system and the stations that from it. Radials give access to information of the radial data of each of the stations that is part of the system, and in this case it's 5 stations. Here we can see the temporal evolution of several parameters, radial parameters, considering their upper and lower thresholds. Total coverage gives access to some plots showing spatial and temporal coverage of the system. To the maps, it gives us the maps of total current of the system at several time scales. Time series radar versus buoys gives access to the comparison of historical data of buoys and grid points of the system in time series format. Current roses radar versus buoys gives access to the service of comparison of historical data of buoys and grid points of the system, but in a system in a way of showing a current rows format, and provides some statistical metrics that is useful for neural time Eulerian validation, and alerts that gives information on active alerts in any of the stations of the system. Thanks to this web tool, an assessment of the need or not of a calibration in a site can be made, and also this tool supports the reliability of all HF radar data, products and services, and in case something is not working, it improves the response, the speed of response, to solve the problem. Okay, I'm now going to talk about some of specific products that we are developing in the project. A generic viewer, a waste product, and a polling index product. They are also under construction, but it will be available in the next months. Okay, rather than a generic viewer, here we can see a generic map viewer with several functionalities. We have the possibility to show the temporal evolution of selected grid points in the same layer on different layers. We have the ability to follow the current velocity along a selected transit. Also, we have a video display section, and we have the possibility to download data in several formats. It's a custom download. No, formats is CSV and NC formats. Regarding waste project, it's a web application of operational observation of waste, different variables of waste, period, height, and direction from HF radar stations. By now, only Vilano and Silleiro, that is validated following Basañez DOL. These parameters are obtained from average readings with colors and tables. And here we have also the ability to obtain the temporal evolution of these wave attributes. And the other project is a polling index. There are operational maps of a polling index throughout the radar coverage calculated by the HF radar, along with other indices, such as calculated by Spanish Institute of Oceanography, and with the ability to follow also the polling index following a selected transit. This novel polling index has been compared with other traditional polling indices to infer the degree of consistency. Results have confirmed the validity of the proposed approach, and therefore the usefulness of HF radar data for the near real-time monitoring of upwelling in other coastal areas where this technology has been successfully deployed. Here we can see the monthly patterns of this upwelling index following Lorente et al. From 2020. And here we can see a current spatial distribution, and that is current is in line with the literature, and also a confirmation a locus permanent upwelling located in Cape Fisterra. Since these maximum upwelling index positions coincide with the two cold nutrient-rich water cores evidenced by satellite, the results appear to confirm the feasibility of the proposed HF radar derived index. And we are also developing this a future project, a combined project consisting of daily average calculated from HF radar, daily average HF radar, also wind and satellite. In this case, sea surface temperature and chlorophyll. They are level 4 projects served by Copernicus Marine Service in near real time within 1 day on the day. Okay, if you have more curiosities about the project and its progress, you can check the website or send us an email. And thank you very much for your attention.